So let me go to Table2Net. You can Google that, Table2Net, with the 2 is a 2, number 2, like this, Table2Net. Same as before, it's an online tool, but it doesn't go on any server, contrary to Cortex. I could shut down the Wi-Fi, it would still work. And it takes a CSV table and it gives you a network because it goes from table to networks. Okay, so you upload a CSV, and I am using here the same CSV as before. That CSV has the column that you can see here, and it's a list of papers from Scopus. They are about climate change. And what I am really interested in here is the authors. So you can see that they have these authors. I am not interested in this case in the abstract, which was what we were interested in with Cortex, but I am also interested in the author keywords and the index keywords. And if you actually scroll, you will see that some papers have author keywords. Those do not have index keywords, but sometimes it's the other way around on both. Author keywords come from the authors. Index keywords come from the newspaper, the journal, the venue where it was published. And I am interested in this because there are multiple of those for each data points, multiple authors per paper, multiple keywords per paper. And because it is like this, I can extract networks. So first, you have in Table2Net to choose which kind of network you want, basically one mode or two mode, which are sometimes called normal and bipartite, monopartite and bipartite. Basically, a normal network has one type of nodes and they are connected by something else. I'm going to make one. So I want to make authors connected by paper. So what is the column representing the paper? The title, for example. Now I have to pay attention to something here. So the authors are multiple per cell. So I have to separate them. As you can see here, this is just a preview of what is going on. It allows you to see that they have not been separated properly. So the internal separator, which may or may not be the same as the separator of the CSV, for this column, it's the comma. So I can say, okay, these are internally comma separated. And now they've been separated well. So the nodes are the authors. This is good. Connected when they have, me changing above has, I have to redo it. Connected when the row has the same title. Alternatively, I could also go for the row number because each paper is in a different row. But you could have a list when the same paper comes multiple times. If that's the case, you have to identify which columns identifies the paper. Maybe they have an ID. In this case, it could just be the title. Good enough. I'm going to go with the title. And then I'm going to ignore all of the rest. And I'm going to build a network. And then it's going to download it. And I'm going to show you that in a second. But I want to show you what happens if you do a bipartite network. Second type of network, bipartite. Bipartite means you have two kinds of nodes now, and they are connected when they appear together. So it looks kind of the other thing I've done before, but instead of having everyone being an author, I can have the author. So same as before, I need to separate them. Good. Connected to a second type of node, connected to the papers. I'm going to use the title again. I'm going to skip the rest. Blah, blah, blah. Okay. So let me go back to Gephi now. First network I have obtained. Okay. We don't see anything. We need to put the layout on the visual. I'm going to do that in a second. I'm just going to also open the second network I have obtained just before. Okay. So let me first apply a basic layout. I have a constellation. So I will not explain too much what I'm doing here, but I want to keep everyone a little bit together and I want them to not overlap. Good. And I'm going to show you. So this is the my constellations. The other one will also make constellations. You will see that. I just want to put colors using an attribute that is called type. And everyone is an author right now. So I have just one type. I'm going to put them red. Everyone is red. This is just a network of authors. Why? Because the papers are kind of in the connections. The authors are connected together when they have written a paper in common. Let me show you the second network. I will do the same. I'm going to also have this little constellations. I am also going to use types. Now the authors, I'm going to still put them in red, are one type, but the other type is title. And title, as you remember, represents the paper. So this one is different because it is, you see the papers, you see the papers. They are not hidden in the links, while in the first one, the papers kind of are the links. So for example, this big cluster here, so Taguchi, Ogohara, Suzuki, Fukuhara, I think that those are authors that are together because they publish at least one paper. I think that they are these guys or these guys. Let me check that. So are they the same? No, I don't recognize. No, Suzuki? Yes, maybe. And what are the other ones? No, so those are other guys. So I think that this is it. Japanese guys. So they have all contributed to this paper called Return to Venus of the Japanese Venus Climate Orbiter Akatsuki. And because they are all connected to that paper, they make this little click here because they have published together. So my network is not very interesting here because my data is not big enough. But basically, the reason to do that is that you would not have like separate groups of people writing papers. It's only interesting if someone has written at least 2 different papers. And you see that just a little bit because my data set is too small. But here we have like a chain of different things. And we have a Liu X, for example, and Feng Q. They seem to have are making some groups, and we should find them here. So we should have some chains of something. Is it here, for example? Yeah, so here, for example, sorry, my label's a little bit big, but basically this, this guy, okay, so these are the same guys. Li Q, as I said before. Li Q has published into 2 papers. They are linked to 2 papers. And Kurtz W8, 2 papers as well. So they are making chains here of papers by having contributed to multiple things. And that would be the real reason to go see into this, to find those little chains, and ultimately they would make groups, and you would see fields and so on, but you need more data than what I have here. So let me just recap. From Table2Net, you can extract a network from a data set that is structured data, as long as you have either columns that come again and again with the same information, or cells that contain multiple values. If it's unclear, you can just try. Then you have to choose which kind of networks you want to extract. Here I have extracted a network of authors and papers, but I could do also keywords and papers. I could even do keywords and authors. So sometimes with a single source file, you have multiple networks you could extract. Next thing, if you extract networks this way, and this kind of speaks to the questions from Jens, when you arrive into Gephi, the layout and the colors are not set, so you have to do it. And then Gephi is really useful at this stage, while with the network out of Cortex, it was ready-made, but here it's not. So you have the need to use those features from Gephi.